All right, we're continuing talking about parabolas. This is chapter 10, section 5. This information for number 3, they've given us two pieces of our parabola. One of them is the vertex, and one of them is the focus. You guys understand your vertex is the h and the k value. All right, so the first thing you do is you plot the vertex at a -2, +4. So there's a point right here. You might want to label it on your paper. You know that's your vertex, which is your HK. Now the focus is at a -2, +3. Okay? So I'm going to call that F1 right there. All right, that's my focus. If the focus is here and the vertex is here, that lets us know that our parabola will be opening downwards. Because this point right here represents my vertex, and if the focus is located right here in this position, you will open downwards. If it was side to side, you would have a vertex right here, and the focus could either be on this side or this side. If it was right here, then you know your parabola would open up going to the right. Okay? So basically, wherever you plot your focus in relationship to your vertex, it lets you know how that parabola opens, whether it opens up, down, left, or right. So hopefully you guys can see that our parabola will look like this. So that's it. Those are our two pieces. From that, right there, we should be able to build the rest of the parabola. But you need to understand the distance between those 2 points. All right? There's a letter that represents the distance between the vertex and the focus. And that letter is P. I want you guys to understand, if this right here, if it's opening downward, that P value will actually be negative. So I'm going to call this, the P value is a -1. All right? Our P value is a -1. If it's opening up or down, here's your standard equation right here. You're going to say x minus h squared equals 4 times p, parentheses y, minus k. So this is the formula right here that we're going to use. We're going to plug everything into. So our equation for this would be x minus h. Well, what is our h value? -2. So if I plug in a -2, that's going to change it from a negative to a positive. So it's going to be x plus 2 squared. What did I say our p value was equal to?
-1.
So 4 times -1 gets me a -4. All right. We're going to say y minus the k value. Our k value is a 4. I put a 4 right there. There's my final equation right there. Now, we're not done because we still need to graph everything. So we're going to graph everything that's a part of this parabola. Okay? If this distance right here is 1 unit, I also know that I need to go up 1 unit and I need to put a point right here because this is where your directrix is going to go through. So I'm going to draw in my directrix. Directrix is going to be in red right there. Our directrix is actually at y is equal to 5. 1, 2, 3, 4, 5. And I want you guys on your paper to label it directrix. I'm going to reset it.
How do you spell that?
I'm about to spell it. D-I-R-E-C-T-R-I-X. Directrix. Okay. Now, the next thing I need you guys to understand is the next thing I'm going to draw on is what's called the lattice rectum. Which is equal to the absolute value of 4 times p. And we know our p value was a -1, so it's just going to equal 4, that distance. Now, the lattice rectum always passes through what point? It passes through the focus. So I'm going to go over 2 units and put a point. I'm going to go over 2 units and put a point. I want you to understand the distance between those 2 points, everybody. That distance between those 2 points is that distance of the lattice rectum. Okay. Now, at this point, I can actually draw my So from here, from the vertex, I want you to go through that point. I'm just doing a sketch, bless you. Doing a sketch, going through the point as best as you can. Alright, there we go. So there's our parabola. We're drawing one more line. And you guys can tell me what this line is referred to as right there.
Isn't that the line of symmetry?
It is the line of symmetry, but we call it the axis of symmetry.
Yeah.
Alright, and our axis of symmetry is located at x is equal to -2. So now I've labeled the axis of symmetry, the directrix, there's the focus, there's the vertex, and that distance that goes through the focus is known as the latus rectum. There's your parabola based off of just a vertex and a focus. Okay. All right, let's look at number 4. And number 4, they give us two things. They give us a focus. So build my focus right here. 2, 1. Over 2, up 1. I'm going to put a focus right there. And it also says the directrix is at x equals -2. Now, x equals -2 is a vertical line. So make sure you draw a vertical line right here where x is equal to a -2. And I want you guys to label this on your paper the directrix. Now, the distance, everybody, between the directrix and the focus, I'm going to label this, call it the only focus I have, right there. What has to go perfectly in between the directrix and the focus? The center. We don't call it the center, we call it the what? Vertex. Okay? So right here, I want you guys to understand, write down, we have a vertex. And the ordered pair that represents that vertex is at a 0, 1, and now we have our h value and we have a k value. So, now that I have a vertex, all right, and I also have a focus which is to the right of it, what does that tell me about which direction the parabola is going to open? So, it's going to open specifically, you can say it's going to open, it's going to go which direction? To the right, so it's going to the right. Okay? Now, if it's going left or right, we have another equation. And that equation is going to be y minus k squared equals 4p parentheses x minus h. So I want you guys to write that on your paper. All right, so now you have this plotted. I'm going to draw in something, and you guys tell me what this distance represents. From here to right there, or from here to right there.
I got it.
All right, what is it, Ryan?
The lattice rectum.
I'm sorry, thank you for blank. This. That's the p-value. All right, so this right here, I want you guys to label. Now, if you're having a conversation which is near my computer, what it does, see, is there's a microphone there, and it picks up those mumbling conversations, which makes it difficult for me to teach. So I want you to label, this is your p-value, which is equal to a 2. So right now, put p is equal to 2. Now, it's not going to equal a -2, it's going to equal a positive 2, because the parabola is opening which direction? It's opening to the right. So if it opens right, your p-value is positive. If it opens left, then your p-value would be negative. All right. Now, I am going to draw in the lattice rectum. This is where all the teenagers chuckle. There you go. And what is the lattice rectum always equal to? That's right. One time during graduation, right, a student got up to speak in front of everybody, and she said, the one thing I'll always remember about Mr. Blue's class is that the lattice rectum is always equal to the absolute value of 14. She said that in front of the full audience.
Why would she say that?
Because it was something that just stuck in her mind and it made her laugh. So, anyways. So what is R? What is this going to equal? If our p-value is 2, what's it going to equal? 8. want you guys to understand, that's the distance. From the focus, you're going to go up. 1, 2, 3, 4. You're going to put a point. Then you're going to go down. 1, 2, 3, 4, and put a point. This distance between those 2 points is 8 units. Okay? So now that you have that plotted, then and only then are you allowed to, it's going to be really, really, really wide parabola, okay? Right? That's a really wide parabola that's opening to the right. So what does it tell you about this value right here? If that's a really large number, it looks like it's going to be pretty wide. If it's a smaller number right here, it's going to be more narrow. So what's our final equation? It says y minus k. Well, what is our k value? Put y minus 1 squared equals 4 times p was 8. And then we have x minus 0. So if it's x minus 0, you can just put x if you want to. You don't have to put x minus 0. Now there's only one thing that I didn't draw in or label. Can you guys figure out the one thing that I didn't draw in or label?
I know it. Symmetry.
Boom. All right. So, Taylor, what would the axis of symmetry pass through? It passes through what? Passes through this point right here known as the vertex, and it passes through the focus. There's only one. Foci, you're right, it was plural. And it's perpendicular to what? What's it perpendicular to?
The focus.
The directrix. It's perpendicular to the directrix.
Oh,
Now, right here, our axis of symmetry, everybody, I told you to label it, would be at y is equal to 1. Okay? So right here, this is all the information that you needed to be able to do number 4.